We're now at the next step for machining our cylinder head, and because this is a 5.3 engine, it came with the 1.889 or 1.889 outside diameter intake valves. It's a common upgrade to go ahead and put in the 2-inch valves, and you can see the difference in the valve length. Let me line them up here on the bottom, and see that this intake valve here, which is a 2-inch intake valve, is considerably longer. So we're going to go ahead and go with just replacing all the valves with some 2-inch valves. Not that any of the intake valves were bad, but it's something that it's pretty commonly done just because there's a benefit in bigger intake valves. So what I need to do first is install the tool into this, or the valve into this tool. And what it's got is a pointer out here on the end, and I'm going to point onto that face where I want the valve seat to sit. So I'm just going to tweak it out a little bit. I'm going to bring it closer together. You can see the point's getting pretty close here, so I'm going to push that in and then slowly slide the valve in, and I'm eventually going to get it to meet exactly where I want it. And what this is doing is setting up a gauge so that I can adjust the cutting tool. All right, that should be good right there. I can tell from there. Now, I'm going to remove the valve from the tool, and I'm going to install this pilot. This pilot is going to mimic the valve guide over here so that I can install the cutting tool, and this is my cutting tool. So there's the cutter body, the insert, which is this blade out here, and then there's an insert holder that attaches the cutter to the actual cutter body. What I need to do is now dial or screw the adjustment screw inside here out until I can see on the cutting insert where the seat angle is. I'm going to have it go out and match the position of the pointer to where I have it on the seat cutter. So let me loosen this up. I'm going to back it off just a little bit. So I'm going to do this under the microscope also, so that we can see the evidence of this. So I say a little bit more, and we should be about there. Okay, I'm going to say that's good. So what I've done is I've actually caused this insert holder to slide in that direction, and when it did that, that went pushed this further out to a larger radius. Because we're going to be machining the valve seat and the cylinder head, and it's a circle, so there's a radius component to it. I'm just going to put it back in. I'm going to verify it's hitting where I want it. Okay, now I'm going to make sure I didn't bump it, so I'm going to put the valve back in to verify that it's hitting where I want it on the valve. All right, so let me take us over to the microscope so we can see it in higher definition. Here we are at the microscope, and we can see that the pointer that was on the tool is this piece here, and you can see it comes down to a fine point. And here's our valve face right there. Now I want that valve seat to contact the valve face, not all the way at the end of the face. I want it to contact at least a little bit in, usually about 10 to 15% the width of it. I want to be just down away from the margin on this valve face to seat contact. So I can see that the pointer is set up to where it's contacting it in a pretty good location for the valve machining, the valve seat machining. So before I bring over the cutter, or the whole cutter body, I'm going to slide a cutter underneath the light here. Alright, so This is the valve seat cutter. There are different ones available, all different angles and dimensions. And this is a piece of tungsten carbide. And what it does is, this is the cutting edge right here. Now in this cutting edge from the manufacturer, and this one's made by Newen, they have ground in the angles, and this is a 3-angle valve seat cutter. We can't see them too perfectly from this angle, but when I roll this insert cutter over and I put it back under the light, we can see the different facets. So this face over here is the one we were just looking at, and we can see we have a facet here, then there's a short facet there, and then a facet out here. So we have our 3 angles. Here's our top cut, our 45, and then it looks like this one's going to be a 60-degree throat cut on this design, or on this specification here. So we can get many different types of valve seat cutting inserts. Some will have wider seat cuts, some will have narrower. Some will have different angles on the top and different angles on the bottom. And the one that I'm going to be using in this application is actually considered a performance variant of it, because you can see, instead of being very angular, this one has very angular, and it's actually pretty short, the original one that we looked at. We can see that this one here is much longer. It also has radiuses. Well, this one has just sharp points, and there's also intersecting points between the throat cut and the seat and the top cut. This one here uses radiuses. So our valve seat angle is actually somewhere around in here, and then there's going to be an intermediate angle in between the valve seat angle and the actual throat cut. And then the same thing here. There's going to be the valve seat angle, our top cut, and then there is a transition radius up here. And this is considered, you know, high performance, because it's going to create more of a, what do you call it? More of a smooth surface going through from the port. So we can see at this angle here that we've got our bottom, our throat cut here, then there's an intermediate radius there, and then right in here, from this point to this point, that is the actual seat cut. Then from the seat cut up this way is our top cut, and then we see there's a radius, and this radius is used to de-shroud the valve so that it flows better. And this is the profile. Now, where I've actually put the pointer was pointing right at this line here, okay, and that line is the top of the valve seat. So when I put this down into the valve seat, valve guide and valve seat area, it should land perfectly in the right spot. Now, I'm going to be machining this valve seat bigger than the original, because the original had smaller valves, so we're going to be machining out more than just the worn section of the valve area. So let me reposition over to the seat and guide machine, and we'll keep going from there. We're over here at the valve seat and guide machine, and what this is just a more precise version of a drill press. I can control the angle of the cylinder head mounted on this fixture. I can control the angle of the spindle that's up here out of the shot. And see, I've got the valve seat cutter installed onto the pilot. So there's our pilot. It's down into the guide. It's pushed down into the guide, and there's a bit of interference fit between it and the guide, and you'll see that it's going to spin on that center line. So I'm going to dial down the valve seat, called the VGS spindle. And you can see it comes into contact with it. And I've got to rotate the body for the pin to catch. And now we're ready to machine the seat. Now you're going to notice in this one we're going to be machining the inside diameter of the seat quite a bit because we're putting in a larger valve. As it's spinning, I'm slowly turning the hand wheel so that it cuts deeper and deeper. Alright, so I haven't reached bottom yet, but what I'm going to do is put some ink on the valve seat just so I can see if I cut it. Let me put some ink back here and around there so that maybe we can see it get machined away while it's running. We're starting to machine the ink off. I'm just going just until I can see the top cut start to form on the seat. Don't need to go any deeper than that. Okay. So I'm going to back it out. Raise up the spindle and turn it off. And there we have a machined seat. So at this point here is when some machine shops would apply lapping compound to the valve. They put a little bit of lapping compound, put the valve in the seat, and then rotate the valve back and forth to see where the seat is actually hitting the valve. And what I'm going to do is just use ink to set that up instead of using lapping compound. Because with lapping compound, you do need to follow it up with remachining the valve face and also machining the valve seat a little bit deeper. So let me vacuum this off so we can see what it looks like. And grab our valve. Alright, so I've got the valve, I've blown it out, and I need to remove the pilot. I've blown it out. Now I've just got to remove the pilot. I'm going to blow down through the valve pilot or the valve guide again just to make sure that there's no chips in there. There we go. And we're just going to drop the valve in to see how it sits. There we go. You see how it's bouncing? That's usually a pretty good indicator that the concentricity of the seat and the face are very close to each other, meaning they're on the same center. Now what I'm going to do is put a little bit of the same ink on the valve face, and I'm going to put it in the seat, and then I'm going to rotate it back and forth just enough for the seat contact to wear that ink off of the face, and that's going to tell me where I am contacting it. There you go, we pull that out, and it seems like we might be a little bit low. Let me try that again. Yeah, it looks like we are a little bit low. But honestly, that's it. That's the bottom end of it. So the seat contact was a little bit low on the valve, so I'm going to go ahead and cut this bigger. I've adjusted the seat out, or the seat cutter out a little bit. So we're going to go in and give it another go. But I still need to put ink on it just so I know if I'm cutting the seat, because it's all shiny now. After machining it gets shiny, and I normally go from a matte finish to a shiny finish. So let's cut this again. Didn't take as long because I'm not taking off as much material. I'm just going slow, partly because this machine prefers a slow spindle speed, and it's a little bit easier to watch. So we're starting to cut the seat. Like the seat is cut, and I'm going to do the same as before. I'm going to wait until I get the top cut to show up. And there it is. So we're ready. Go ahead and back it off. There we go. Now we have our new diameter. So let's go ahead and remove the pilot and the cutter and the spring. I'll vacuum it out and blow it out. Grab this valve again. I'm going to go ahead and re-ink it. See if I can wear it away. That's better. It's up higher than it was before. Let me take it over to the microscope. So So over here at the microscope, we'll see where in the valve face it's contacting. We can see that the valve seat is contacting the valve face right through here. And that's exactly where I wanted it. So if you could imagine, or not imagine, but remember that the angle that we talked about earlier, that 45 degree on the valve face or valve seat, on this one was from here to here. That is what's been cut on the valve seat in the cylinder head to create a concentric valve seat. Now the next thing I like to do before I go any further is to actually test the seat. After each cut, I test the valve seat to see if it'll hold vacuum. So I've got a vacuum motor and a vacuum gauge here. Let's see, there we go. So it's just a regular vacuum gauge. It's just my mobile one that I set up for this purpose. And I've got this vacuum pad here. I'm going to put this pad over the intake port, and then we're going to watch the vacuum gauge and see what it gets. And this is with no pressure down. So I'll activate the vacuum. There we go. So without any pressure, any touching, it looks like we're getting, now this gauge is skewed a little bit because a perfect vacuum is about 28 inches. So this gauge is skewed, and the fact that the port is so big, my pad doesn't quite cover it all, so we got leaks there. There we go. Let's try that. There we go. So what I'm going to do, because this machine does tend to chatter a little bit on the seats, I'm going to get a valve grinding stone, and I'm just going to do it by hand just to lap down any high spots on the valve seat. So we're just doing this by hand, and it's already set to a 45. And it's just going to take off any of the high spots caused by chatter. Take that out, this back out. We're going to blow it back out because of any chips or grinding dust that get stuck in there. And let's see if it gets better. So we're going to install that guy. Grab the vacuum. There we go. There we go. So just a little bit of stoning to get rid of any chatter marks, and then this is how much it's going to seal. Now, a perfect seal on this gauge can range, say 25-ish, but if I tap the gauge, it moves. But like I said, this is my mobile gauge for the video, and this is what we're getting out of this valve here. There we go. So, we just got a leak in the pad. And that is machining a valve seat. That just gets repeated with the same cutter on all the intake valves, and then an exhaust cutter is it's the same body and similar holder, but we see that there's different diameters because obviously the exhaust valve is smaller in diameter. But it's just another body, another holder, and a different insert because it's going to cut a wider seat, because exhaust, it's advised to have a wider seat on the exhaust valves. So it's just that there again, just a repetition from one to the other. So I'm going to back the camera off so you kind of get a larger overview of the action, and maybe get some more out of it. All right, so here's a wide out shot. I'm going to go ahead and set it up so that I have to do leveling again on the cylinder head. So I've got my pilot. I'm going to stick this down into the intake valve guide for the one that I'm going to cut next. Now, I don't need to level this thing every single time I want to cut a seat. Normally, if you level it off of one, then they're good for all the others. There are some heads that are an exception to that, where the valves are actually all at different angles. So let's go ahead and set up the leveling. So this right here is just a bubble level, and I've got to adjust it just to get it set. And I'm going to put this down on the cylinder head. So this little pilot right here is in line with the spindle. So everywhere the spindle goes, this pilot goes, and they're both leveled off with each other. So I'm going to loosen up the cylinder head fixture, and you can see that I can rotate this around like that there. So I'm just going to do a rough adjustment just by tapping on it. And then I've got an adjustment out here on the right where I can dial it in a little bit closer and then lock down the clamps on each end to where that bubble is level in this direction here. So now I've got to turn this bubble level 90 degrees. I'm going to worry about the level measurement across the length of the head. So I've got to adjust it to now match the angle of the valve guide. Now take it off the valve guide pilot. I put it on that same pilot up on the machine, and then I can adjust, well, it's already in, but I can adjust the spindle left or right so that it goes down at the appropriate angle. Now that I've got the pilot lined up and the spindle lined up on the machine, put in the bounce spring, put in the actual valve seat cutter. Now this whole fixture is actually an air float, so it actually has air plumbed into the bottom of this plate, and that means it will float effortlessly, so that I can now put the spindle on the same center line. There we go. So it's on the same center line. Let me adjust that a little bit. See if it gets any better. There we go. So the spindle is now on the same center line as the pilot. Now the next thing that I do with this machine is, because this is an aluminum cylinder head, the only weight that's holding this fixture down is the weight of the fixture and a little bit of the head. So I've installed this clamp block so that it will weight it down more. Because I'm cutting such a large diameter out of the throat of the seat, it would cause this fixture to move around, and I don't want it to move at all. So I lock it down to the table with that fixture, and we just start cutting. Doing the same thing as before. I'm waiting for the valve seat to start cutting. As the insert plunges deeper into the valve seat, it's cutting the ID, and then it'll eventually start to cut the valve seat. And when I see the valve seat and then the valve seat top cut come in, that's when I know I am deep enough. Alright, so the valve base is starting to cut. And what you're hearing is a torque limiter on top of the machine, just to keep me from overdoing the spindle torque. I don't normally cut seats this big. On this machine. There's the top of the seat. Now we're just waiting for the top cut to start to form. Slow it down, do the final cut. All right. Now during a normal valve job, it wouldn't take that long because I'm increasing the valve diameter. I've got to bore the seat out. If I were just cutting the seats to, rebuild the engine and using the original valve seats, it wouldn't have taken but maybe 20 or 30 seconds per seat. But we're doing it the hard way. Now we're going to position for the next one.